It's Moser, back again with your Introduction to Reaction Stoichiometry, Part 2, the good stuff. So your learning goals for this video are, by the end of it, you should be able to solve any reaction stoichiometry problem. No pressure. Moles to mass to moles, or mass to mass. To do that, what you're going to have to know in advance is how to write a balanced chemical equation, how to derive the mole ratios from it, and how to find the molar mass of any compound or element. Okay, let's get started. You may remember that in the last video, we established that there are four basic types of reaction stoichiometry problems, where both the given and unknown have quantities given in moles, or where a given is in moles and the unknown is in mass, where the given is in mass and the unknown is in moles, or where both the given and the unknown are in mass, in grams. I will say that this is by far the most common and most real-world type of problem because, again, there is no such thing as a mole balance. If you want to actually know how much of something you need, you're going to have a mass in grams. All right, where do we start? Aha, with a balanced chemical equation and the mole ratios that we can get out of it. Let's do a mole-to-mole problem. In our first problem, we're asked to predict how many moles of water will be produced when 15 moles of phosphoric acid reacts according to the equation above. Now, stoichiometry problems are always solved using factor label, and we always put what in the first box are given. In this case, 15 moles phosphoric acid. Now, note that I have used both a unit and a chemical, and I've been stressing this since the beginning, but this is where it really gets important, because you're going to have multiple chemicals and eventually multiple units in the same factor label. So if you don't have both of those, it could cause you problems, and having them just gives you a nice breadcrumb trail to trace back. Well, we know that we want the units in the chemical in this box to match these so that it'll all cancel out. So I've done that, and I know that I want the units in the chemical up here to be what we're going to end up in, which in this problem is moles of water. So now I've got that all set. Where do I get my mole ratio? Because that, in fact, is what's going to go here. Mole ratios, the heart of any reaction stoichiometry problem. Well, I'm going to look up here to the coefficients in the balanced chemical equation, and I find that there are 3 moles of water produced for every 1 mole of hydrogen phosphate that reacts. So, how many moles of water will I produce from this 15 moles of hydrogen phosphate? 45 moles of water are produced. Now, note, I didn't do it formally, but you should make sure that all your units and chemicals cancel, leaving you with what you want to end up in. Okay, well, let's do the next kind of problem. So this is a mole to mass problem. Our given, in this case, is 11 moles of potassium phosphate, while our unknown is a mass of potassium hydroxide. I'll read it to you. What mass of potassium hydroxide will be needed to produce 11 moles of potassium phosphate? Since we always start with our given, let's go ahead and do that. So I've put my given in. Now, this gets a little bit trickier because, again, I know that I want my units and chemical here to match what's given here so that they'll cancel, which means I'm going to have moles of potassium phosphate there. And I know that I want to end up in grams of potassium hydroxide. But there's no way to go from moles of potassium phosphate to grams of potassium hydroxide. I have to go through my mole ratio, which means I need to look for a mole. I need the conversion here in the middle to be moles of potassium hydroxide. I'll go ahead and put the rest of my units and chemicals in before I pull the numbers out of the equation and the periodic table. Well, again, I know that I want the units and chemical here to cancel the units and chemical here, just like this units and chemical canceled this units and chemical. This is great. It's a good setup. There's only one last thing. Can I go from moles of potassium hydroxide to grams of potassium hydroxide? You betcha. Grams, K-O-H. So, now that I have all of my units and chemicals in place, I need to figure out where my numbers are coming from. Alright, I know that that mole ratio is going to come from my coefficients of potassium hydroxide to potassium phosphate. And if I look up here, I have 3 moles of potassium hydroxide for every 1 mole of potassium phosphate. Great. Now, what about this? Well, what's the relationship between moles of potassium hydroxide and grams of potassium hydroxide? its molar mass. So you need to work out the molar mass of potassium hydroxide. Okay, 56.11 grams per mole of potassium hydroxide. And if you write the units like that, it even reminds you where everything goes. 56.11 grams potassium hydroxide equals 1 mole of potassium hydroxide. Now I can do my multiplication. You end up with a raw answer of 1,851.63 grams of potassium hydroxide, but of course we're limited to the 3 sig figs that were given in our problem. So our final answer will be 1,850 grams of potassium hydroxide, which is a very good ballpark figure. Okay, let's do mass to moles. So I'm being asked how many moles of phosphoric acid are needed to produce 150.0 grams of potassium phosphate. Again, our given is in mass, grams, and our unknown is in moles. So let's get started with our factor label. Well, I put my given in 150 grams of potassium phosphate, but I can't go straight to a mole ratio because I can't go straight from grams of potassium phosphate to a mole ratio between the phosphoric acid and the potassium phosphate. I'm going to have to get into moles of potassium phosphate first. How do I do that? Why, with the molar mass, of course. So I'm going to go ahead, and I know that my units and chemical here must cancel, and I want to get into grams of potassium phosphate so that I can use my mole ratio. I'm not going to put in any numbers yet. I'm going to continue to go ahead and put in my units and chemicals, making sure at each step that they do in fact cancel. So if I stopped right now, I would be in moles of potassium phosphate, but I want to go on to moles of phosphoric acid. So to do that, I'll have to do my old mole ratio. I want moles of potassium phosphate on the bottom and moles of phosphoric acid or hydrogen phosphate on top. If I go back to my balanced chemical equation, I see that these exist in a 1-to-1 mole ratio. Fantastic. Now let's plug in our numbers for molar mass of potassium phosphate, and I see that 1 mole of potassium phosphate is equal to 212.27 grams of potassium phosphate. Time to do some math. Okay, I get a raw answer of 0.706647195 moles of hydrogen phosphate or phosphoric acid. I did make sure that my moles of potassium phosphate canceled, and I was left with moles of hydrogen phosphate. Now, how many sig figs am I limited to based on my givens? Good question. 4, which means I'm going to stop my number right there, and I'm going to round based on what comes next. Okay, final answer, 0.7066 moles of hydrogen phosphate. We've only got one more kind to go. Okay, so we're working with the same equation. I'm now being asked, when 500 grams of potassium phosphate are produced according to this reaction, what mass of water will also be produced? So note that both my given and my unknown are in mass. They're in grams. I'm going to start off with the mass of my unknown, and you'll note that I've left myself lots of space because this is going to be a many-step process. So obviously I can't go straight from grams of potassium phosphate into a mole ratio. I need to get into moles of potassium phosphate first. And the first piece that I know is that the units in chemical here have to match what's going to go down here. So I'm going to go ahead and put those in. I know that I need grams of potassium phosphate here to cancel, and I want to end up in that first step in moles of potassium phosphate so that I can use a mole ratio. Okay, well if I stopped right now I'd be in moles of potassium phosphate, which means I'm ready to get to my mole ratio. I'm going to use, of course, moles of potassium phosphate here to cancel. And since I want to get into mass of water, I know that up here I'll have to get into moles of water for my eventual conversion of that over to a mass of water. Okay, checking so far, this will cancel, these will cancel, so I need to put moles of water here, and since I want to end up in mass of water, my final box at the top will be grams of H2O. Okay, double checking that, everything I want to cancel cancels, and I end up in the correct units in chemical. I'm now ready to plug in some numbers. Well, I know from the calculations I did in the last problem that 1 mole of potassium phosphate is equal to 212.27 grams of potassium phosphate. And if I look at my balanced chemical equation, I see that there is a 1 to 3 mole ratio between potassium phosphate and water. So the 3 is going to go with water, and the 1 is going to go with potassium phosphate. Now, I did a little bit more math and found that 1 mole of water equals 18.02 grams of water. I am now ready to do my calculations. I get a raw answer of 127.3378245 grams of water. And being as that I am constrained to 4 sig figs based on my given, I'm going to stop my answer right there, giving me a final answer of 127.3 grams of H2O produced. Okay, let's just review a few things. The mole ratio is the heart of every reaction stoichiometry problem. So, if you're starting in moles and ending in moles, it's pretty easy because it's one step. Just like that. But, if you're starting in moles and ending up in mass, you have to add another step to that. Note that the mole ratio hasn't changed, it hasn't moved, we've just added a conversion from moles to grams on the end. What if you're starting in grams and ending up in moles? I'm glad you asked. Oh, we just put another step on the front. The mole ratio stays there. Now, what if we are going all the way from the mass of one to the mass of another? Easy peasy, we just tack the conversion onto the end. We can go from grams of one thing converting to moles using a mole ratio to get into moles of the second thing, and then tacking a conversion from moles to grams onto the end, giving us grams of our second product, or our second chemical. Okay, that's it. You've got plenty of practice. Get going.